Hello everyone, welcome to the first part of the English version of the webinar series Analytical Characterization of Starch. I will then continue with the first case studies where the separation mechanisms of starch suspensions was investigated. Then I will present you a case study about starch paste. Before the last case study, I will talk about the associated technology. Finally, there will be a short summary and outlook. After starch suspensions have been heated to starch paste, the LUMI and LUMISizer can be used to analyze dispersibility, separation stability, particle size distribution, and also agglomeration and the concentration of sediment volume. Dried starch pastes and starch gels can be examined with the LUMIFRAC to determine the adhesive strength, rapid separation of the samples. I now turn to a second case study where starch and flour suspensions were investigated in the centrifugal field. The sedimentation, packing, and compression behavior of the samples were compared. It had a significantly higher sedimentation speed than the flour products, with the potato starch having the highest value and the cake flour the lowest. In summary, the STEP technology allows to characterize and quantify the segregation behavior at gravitational and at centrifugal acceleration. This analysis made it possible to detect the separation mechanisms as quickly as possible and to examine the entire sample length. As can be seen here, the sedimentation rate of the starch with contamination was lower. Starch pastes achieve higher forces on steel than on polyamide, and the standard deviation for starch pastes on polyamide is larger. This webinar is the first part of a webinar series on starch. In the second part, I will talk about starch as an emulsion stabilizer. Hello everyone, welcome to the second part of the English version of the webinar series Analytical Characterization of Starch. Today I will be talking about starch as an emulsion stabilizer. I will present various literature examples where the stabilization properties of starches have been investigated. In the first literature example, the stabilization properties of corn grains and starch in coconut milk were compared. You can find the link of this article here or also in a literature database. Back to coconut milk. This is a very popular cooking ingredient, however, natural coconut milk is unstable. Therefore, starch with different amylose contents and maize grains were added for stabilization together with various additives. Subsequently, the stability and rheological properties of coconut milk emulsions were investigated. You can also see that the separation starts later at higher concentrations. This slide shows the differences in the stabilization properties of the polymers at different temperatures. A wide range of temperatures could be compared. It can be seen very clearly that emulsion stabilized by the modified starches has a significantly lower creaming rate and for this reason are a good alternative for gamma-Arabic as a stabilizer. In addition, it can be seen that in contrast to this difference, the differences caused by concentration are not significant. You can take advantage of direct and accelerated stability analysis. With centrifugal acceleration, a fast ranking of samples is possible. Further, due to the small sample volume, the use of additional chemicals, cleaning of sample containers, and tools can be avoided.